Hi, 7th graders. Today we are starting chapter 7, which means you only have 2 more chapters left in your school year. Today's lesson is 7.1.1, What is the relationship? So I would like you to take a minute and write your title down, and then open your online book or your textbook, and I'll get you the page number here. Is page 378. Take a minute and do that. Play the video again when you're ready. All right, on page 378, it has an overview on proportions and percents, which what you will be learning about in chapter 7. I would like you to pause the video and write down 3 things that you will be learning about in chapter 7. After you've done that, you can press play again. (7.1.1) What is the relationship? Distance, rate, and time. In this course, you have looked at several relationships between 2 sets of information and investigated how one piece of information can or cannot be found from the other. To continue your investigation of proportional relationships from Chapter 4, you will look at the mathematical relationship between distance, rate, and time. Later in this final section of this chapter, you will identify proportional relationships and use your understanding of proportionality to solve problems. 7.1 is the first one, so please write 7.1 in your notebook. Distance, rate, and time. George stood on the train platform and waved goodbye to his sister as she left for summer camp. Later, as he was getting into his car to drive home, he saw a light flashing inside the train station and heard an announcement that his sister's train had malfunctioned and was stuck on the tracks. George had a map of the train's route and decided to drive to where the train was stuck and pick up his sister. How can he figure out where the train is? What information would help him figure it out? Be prepared to share your ideas with the class. So I would like you to pause the video for a second and write down your thoughts. After you have written something down, I would like you to find a partner and share with quick and see what they wrote down. If they wrote down something different than yours, make sure you add to your answer. Once you've talked to someone, it should only take you about 30 seconds. I would like you to play the video again. Okay, so I'm going to share with you what I hope that either you wrote down or you talked to a partner about. And so the train's map helps, right? So how can you figure out where the train is? He would need the map to know where the route is. Then he needs to know how long the train had been traveling for, because it says after a while or later as he left, we need to figure out how long that actually was. And then we would need to know the speed of the train. So if the train was going really slow, it might not have gotten very far, but if it was going speedy, maybe it did get really far. So those are 3 things that would be really important, and that's where we're going to get into distance, rate, and time today. That you need to know the time something's been happening, and the rate it's going at to figure out the distance in this case. So if you don't have those things, make sure you add those to your answers on your paper. Okay, 7.2, I am going to read to you, and then you are going to use mock data instead of actually using these toys. It says, if you needed to predict how far a car, train, or plane had gone, it would be helpful to know something about how fast it was going and how long it had been moving. You will work with your team to investigate the relationship between distance, speed or rate, and time in the following experiment. So it says to obtain a meter stick, a toy, such as a wind-up car, a long piece of paper, and a stopwatch from your teacher. Put the paper on the floor, draw a starting line near one end of it, and place the toy on the edge of the paper, facing the starting line as shown at right. Place the toy a short distance behind the starting line so it can reach the constant speed by the time it gets to the starting line. Read the directions below for taking data before starting your toy. So it wants you to time, and they want you to see how far a toy can go when you wind it up and let it go. So I would like you to pick a sample data. So this would be that the car ran for 5 seconds and it went 8 centimeters. A car ran for 15 seconds and 15 centimeters, and then at 15 seconds it went 23 centimeters. So I would like you to pick if you want to be on team 1, team 2, or team 3, and then I need you to copy this T-chart down exactly, whichever one you pick. So you don't have to do all 3, you just pick which team's data you want to use. So pause the video and copy one of those T-charts down. Okay, so you should get a resource page from your teacher. Work with your team to organize your data into a table and graph it. Be prepared to share your table and graph with the class. Then think about the following questions. Where does the graph begin? Should your graph stop? Would it make sense to continue your graph to show how your toy would travel if you were to continue measuring for more time? And how far would you expect your toy to travel after 7 seconds have passed? What about after 2.3 seconds? Does it make sense to connect your points on the graph? Why or why not? So if you look at your graph, you can see that on my Y, so that's going up and down that axis, is distance in centimeters. And then below is time, and they have the 5 seconds, 10, 15, and 20 listed. So what you're going to do is you're going to take your data from the table that you just copied, either one of these, and then you are going to plot the points on there. So you'll find the time, and then you'll figure out distance. So you need to figure out how to number your centimeters on the y-axis, and I would probably do 5, 10, 15, 20, 25 if it were me, because it looks like these go not too much higher than that. So that probably would make the most sense if each smaller line was worth 1, and then each of the points here is 5. So 5, 10, 15, 20, 25 would probably work best. And then you'll plot each of the points. So you should have 3 points listed. And then you need to answer I and II in your notebook. So this is something that you're going to have to stop the video for quite a while for. You want to plot your points, and then you are going to do your answers for I and II. If you aren't sure on how to plot the points or how to make predictions for II, this is a point that you need to raise your hand and ask a teacher, because this is important that you're able to graph and make predictions by this point. So please pause the video and take time to do all of those steps. Okay, I wanted to show you an example of my graph. So where does your graph begin? It should be at 0, 0, because at 0 seconds, your car should go 0 centimeters. That should make sense. Should your graph stop? It should not stop. It should keep going, because you could predict that if I ran my car for longer seconds, that it would probably go farther. But it might end up not. There might be a point where the car stops, because wind-up toys only last for so long. But I could assume that maybe 5 more seconds to 20 seconds it could keep going, and then eventually I think that we would see it stop somewhere. This is just an example. It might stop here because the car can't move anymore. It doesn't have enough juice to keep going. All right. Then, how far would you expect your toy to have traveled after 7 seconds? So I'm going to look at 7 seconds. So this would be 7.5 here, because that's halfway between 5 and 10, so it'd be a little less, maybe like here. So if I go up to 7 seconds and go over, that would be like 11, because this is 10 we talked about earlier. So after 7 seconds on my graph, I would expect my car to go about 11 centimeters. Yours should be something similar to 11. What about after 2.3 seconds? So we said each line was worth 1. If I go 1 second, 2 second, a little bit more, and then over, I would expect my car to go, if this is 2.5 here, I would guess, I don't know, maybe only for 1 second would get me to, oh, I have to guess seconds, I'm sorry. 2.5 seconds, 2.3 seconds will be a little bit less. I'll go up here. That would be about 4 centimeters. So hopefully you got about 7 or about 11 centimeters for 7 seconds, and then about 4 centimeters for 2.3 seconds. And if you use something other than the first data here, your answers might be a little bit different, but they should end up to be similar. All right, 7.3 and 7.4, I'm going to read, and then you're going to do those on your own. It says, what is the unit rate of your toy? So whatever data you picked, you have to figure out the unit rate. And remember, we said that was when y equals k times x. K is your constant or your unit rate. That is approximately how far does your toy travel each second. How can you see this in your table? How can you see it in your graph? Be prepared to explain your ideas to the class. And then 7.4 is how can you see your answer to problem 7.3 to write an equation relating the time the car has been moving to the distance it has traveled. Work with your team to write an equation relating distance and time. So I'd really like you to try 7.3 and 7.4 on your own. So I'd like you to pause the video and come up with an answer. I will explain after you play how to find each of those answers because it's important to this lesson. So please pause and answer those on your own to start. This one I had to figure out unit rate. So I need to figure out what my constant multiplier is, and that's when x is equal to 1. So I went back to the table that I used, and I saw that it's about 1.5 times x, because this is my x on a t-chart, x and y. X times 1.5 is about 8. It's actually 7.5. 10 times 1.5 is 15. And then 15 times 1.5 is 22.5, so it's pretty close to 23. So I need to figure out when x is equal to 1, what y is. So if I do x times 1.5, that equals 1.5. And my k is my constant multiplier, which is 1.5, and that is my unit rate. So the unit rate is the constant multiplier. So here, my k, I'm going to type this so it goes faster. K, or unit rate, is equal to 1.5 in my case. The way you can see it on a graph is if I look at my graph, then when x is equal to 1, which should probably be about halfway between here, then I go up on my chart and it looks like on here it looks like about 2. So that's pretty close. So I can use either my graph to estimate or I can find the constant multiplier in my table. Now how can I use my answer to 7.3 to write an equation relating to the time the car has been moving to the distance it has traveled? Equation y equals k times x. On my chart here and on the graph I can see that distance equals y. So here I have distance equals the rate is my constant times time was my x. So this is important for you to write down, that distance equals rate times time. This is something that you're going to use in math and in science. So make sure you have that written down. After that, you can stop the video and you'll do your homework 10 through 15 tonight. Good luck and have fun.